Hi everyone, and welcome to EasyEDA. In the last lesson, we walked through setting up the software environment. Now it's time for lesson 2, where we'll cover how to configure library files. We're going to break today's content into 4 parts: configuring external libraries, creating an image library, importing built-in libraries, and finally a quick wrap-up. Let's start with external libraries, that is, the driver libraries. We'll jump right into the VS Code to demonstrate how to set everything up. What you are seeing now is a project structure we already created in the last lesson. Now we're going to import the libraries we'll need. So, how do we import them? First, click the Platform I/O icon on the left. Here, you'll find a section called Libraries. Alternatively, you can go to the top menu and choose Open and go to Libraries. Both will get you to the same place. Next, type the name of the library you want in the Search Libraries box. For example, if you want to use web features, we'll search for a web server. First result that comes up is one we need. Let's take a look at what's on this page. You can choose which version to install, either the latest one or a specific stable version. You'll see a button here that says Add to Project, but we don't recommend using this method. It's a bit more complicated and error-prone, so we'll skip that. Example is that the session has example sketches. Like here, it shows 3 examples that can help you understand how this library works, such as how to create a web page. And the installation. This is the important part. It tells you exactly what to add to your platform.io.ini file to include to the library as a dependency. Just copy this line and paste it in. There are 3 installation options: install specific version only, install the version to receive future bug fixes, and install the version that get both bug fixes and new features. We recommend the third option, but feel free to choose whatever works best for your needs. This section lists the header files used by the library. Once you download the source, you'll see them in your project, so we won't go into the details here. In channel log, you can see the library's update log, what features we added, what bugs were fixed. This is super helpful upgrading later. And lastly is the tags, platform, and framework. You'll also see what keywords, platforms, and frameworks the library supports. For example, it supports ESP8266 in Arduino, so it's fully compatible with our project. Now let's go back to the installation section, copy the lib/deps line, and paste it into the platform.io.ini file. So, why are we using third-party libraries instead of writing low-level code ourselves? Because these libraries save us a lot of development time. If you were to start from scratch, say manually controlling GPIO pins or handling timing, you'd be looking at a long, painful process. And debugging will be a nightmare. Take screen drivers, for example. If you wrote everything from the ground up, you'd need a logic analyzer just to check timing waveforms. Even a small mistake can make the display to fall in and fail to turn on. Why go through all that? These open source libraries already handle all the low level stuff for us. All we need to do is focus on application level development. We're going to use 4 libraries in total. Web server, this lets us control things through a web page. For example, controlling our Robotdog using a browser. U8G2, a screen driver library. It supports SSD 1306 displays, but even though we're using SSD 1315, they're fully compatible under the I2C protocol. NTP client gets the current time through the network time protocol. It's way more accurate than using a standalone I2C. Arduino JSON help us handle JSON data, for example, parsing API responses or saving Wi-Fi passwords. Sure, you can manually build strings without this, but it'd be a pain. Let's go ahead and add all the libraries we just talked about. Actually, we already gone over these earlier, so it should feel familiar. Now it's time to officially add them to our project, then move on to creating an image library. The process is exactly the same as before. Go to Library section in Platform I/O. Search for the library you want, say U8G2. When you find it, click Installation. Copy the line of config it shows you, then paste it into your platformio.ini file. Each one goes on its own line. Next up is Arduino JSON. Same thing, copy the config, paste it in. Then we'll do NTP client, again with the same steps. And with that, we finished importing all the commonly used libraries. Now open up your main.cpp file. In bottom left corner of VS Code, there's a little checkmark icon. Click that to start the complication process. Once you hit compile, Platform I/O will stop pulling all the third-party libraries we just added. You don't need to do anything here, just wait for it to finish downloading. When it's done, you'll see those libraries inside the .pio folder under lib deps, libdeps. They'll all be downloaded and ready to go. For example, the source code for the U8G2 library will be right there, along with every individual driver, like GU800 and other low-level files. But for our current project, you don't need to touch any of these source code. There's no need to recompile or modify anything inside these folders. So just leave them as they are. No need to mess with them. Alright, now let's deal with the image we prepared earlier. This image is called PC to LCD 2002, and we can zoom in a bit to take a closer look. Now let's open the BMP bitmap file that we got already. This BMP format is actually pretty common. We can find pre-made images on open source platforms or on Wiki's website, so feel free to download one directly. Of course, you'll want to make your own custom image that works too. Just keep in mind, you'll probably need to use Photoshop to convert your design into BMP bitmap format, and one key to pay attention to, the resolution. You'll notice we've already listed some standard resolutions, like 128 times 64, 64 by 64. These are the resolution we already used across the board. Can you use a different size? Technically, yes, but if your image is too large, it might not display completely. Plus, bigger images will take up more space, so it's not always ideal. Once you import the image into the software, you can even edit individual pixels by hand. Here, you can see we're able to tweak the pixel layout manually. But to keep things efficient, we won't spend too much time fine-tuning the image manually for now. Next up, how do we export this image? Let's check export settings. By default, the format is set to A51, but we need to change that to C51. The output mode should be set to row, which is already our default configuration. No need to change it. One small but important detail, make sure to remove the parenthesis line in the prefix and suffix. Once that's all set, click OK and then click Generate Font. At this point, the software will generate the corresponding array for us. Alright, that's it for the image prep process. Next, we're going to create a new file and store the image array inside it. Go to your project folder, find the src directory, Then right-click and choose New File. Be careful, not a new folder, but a new file. Let's name it image.cpp. Now that the file is created, the first step is to include the Arduino library. Then we define a starters type for our array. Let's call this array high. You might see an error warning pop up while writing. It's fine. The editor just hasn't caught up yet. Once we compile, the error should disappear. We can use the exact same method to import new images. But before we move on, let's take a quick look at the definition we just used. Const uint8/t high bracket progmem. Why do you write it like this? First, uint8/t means an unsigned 8-bit integer, and that's exactly what the UAG2 library's draw xbmp function expects. If you change this type to something else, like a 16-bit integer, it won't work. The function will throw an error. Next, progmem is a keyword that tells the compiler to store this array in flash memory instead of SRAM. Since image arrays can be pretty large, putting them in SRAM would eat up a lot of memory. So using progmem helps us save space and make things more efficient. Alright, let's import this image array into our project. We've still got a bunch of images to add, but we won't go through every single one here. You can just follow the same steps and process each images one by one. Alright, by now you should successfully configure the external libraries and add your image libraries. Next up, we'll import everything into the main program. At the top of your code, let's start by adding the necessary header files. Some of the libraries we were about to include were already covered in earlier chapters, especially during the sections on driver library setup and web library integration. We talked about what they do and how to use them. Now let's focus on the remaining internal libraries, most of which are built into Arduino or ESP8266. You don't need to manually download them, they're ready to go. First, the basic Arduino code library. This provides essential functions like serial communication, delay, digital I/O, basically everything we use in Arduino programming. Next, the servo library. This one helps us generate specific PWM waveforms, which is super handy when controlling servo motors. You can use it to set frequency, post widths, and so on, basically control all aspects of servo movement. Then we got the FS library, the built-in file system for ESP8266. It's used for reading and writing files in flash memory. Very useful when you're storing config data or logs. Next, the ESP8266 Wi-Fi library. This one's also built in and lets you create hotspots, connect to routers, and so on. We'll definitely need it when we start controlling devices over Wi-Fi. Then there's the Wi-Fi UDP library, which is specifically used in combination with the NTP client. Since NTP runs over UDP, you'll need this library as a dependency. Then we'll import the U8G2 display library, which is what drives the screen. After that, bring the web server library. We talked about it earlier when we built a local web interface. Next is the NTP client library, which syncs time over the internet. Remember, it depends on the UDP library. And finally, we'll add Arduino JSON, which is incredibly useful for parsing JSON data. Whether you're getting responses from the server or handling web interactions, this library comes in very handy. Once you're done importing all these, do a quick scan of your header section. Make sure you didn't miss anything or make a typo. Check if all libraries you need are there. And that's it. Now your core libraries are fully set up. In this lesson, we covered 3 major parts. External library configuration. We learn how to use Platform.io's library manager to find and import third-party libraries by editing the project's config file. Creating an image library, we went through the process of converting images to byte arrays, saving them in Flash, and use them for display. Importing built-in libraries, we reviewed the built-in libraries from Arduino and ESP8266, including Wi-Fi, FS, UDP, and how to import them into our codebase. After completing this section, you should now be able to bring in various functional libraries in your project, ready to add more features to your Robotdog. That's all for this lesson. Thank you so much for watching, and I will see you in the next one.